Hello, dear students. This is your Engineering Mathematics 3 lecture. Today's topic is use of multipliers. This is the second method to find the solution of symmetrical simultaneous differential equations. Last lecture, we have already discussed the first method to find the solution of symmetrical simultaneous differential equations. And the first method was of grouping method. Now the second method is use of multipliers to find the solution of symmetrical simultaneous differential equations. This is the topic from first unit, LD, linear differential equations with constant coefficients. Now, how to find the solution for symmetrical simultaneous differential equations using the multipliers? See, we know that the property of ratio and proportion. Now, the form of symmetrical simultaneous differential equation is dx upon p is equal to dy upon q is equal to dz upon r, where p, q, r are the functions of x, y, z. Now, using the property of ratio and proportion, we can write this symmetrical simultaneous differential equation dx upon p is equal to dy upon q is equal to dz upon r is equal to L dx plus m dy plus n dz upon Lp plus mq plus nr, which is also equal to L1 dx plus m1 dy plus n1 dz upon L1p plus m1q plus n1r. Now, what is here L, what is m, what is n here, or what is L1, what is m1, what is n1 here. This is the set of multipliers. LMN is the first set of multipliers after multiplying P by L, Q by M, and R by N. If we do the addition of all the terms LP plus MQ plus NR, then it is equal to 0. If it is equal to 0, then LMN is the first set of multipliers. And we are multiplying that P, Q, R by L, M, N respectively. So you multiply the numerator also by L, M, N, so that you will get the term L dx plus M dy plus N dz. Similarly, if we multiply P, Q, R, the denominator terms by L1, M1, N1, and we do the addition of all the terms, then the addition is 0. And in that case, L1, M1, N1 is the second set of multipliers. Now we are multiplying the denominator terms by L1, M1, N1. So you have to multiply the numerator terms also by L1, M1, N1 respectively. So that we will get the numerator term L1 dx plus M1 dy plus N1 dz. So here is the explanation, where L, M, N and L1, M1, N1 are the multipliers. They may be in the form of variables or constants. Where Lmn and L1, M1, N1 are the multipliers, constants or variables. They are in the form of variables or constants. We choose Lmn and L1, M1, N1 in such a way that Lp plus Mq plus Nr is 0 and L1p plus M1q plus N1z is equal to 0. N1r is equal to 0. In place of z, there is the term here r. We can replace it by that. This is the term here. It is R, N1R. There is one small correction. So you can, here it is R. Okay. In place of Z, there is the term R. Okay. So Lp plus Mq plus Nr is equal to 0 and L1p plus M1q plus Nr, N1R is equal to 0. Then the numerators are also 0. I have explained it that if we are multiplying that denominator terms by LMN, then we have to multiply the numerator terms also by LMN, so that we have the term LDX plus MDY plus NDZ is equal to 0. If denominator is 0, then numerator is also 0. So we can write LDX plus MDY plus NDZ is equal to 0. Similarly, for the second set of solution, that if denominator term L1P plus M1Q plus N1R is equal to 0, then the numerator term is also 0. L1dx plus M1dy plus N1dz is equal to 0. That is the term here. The term is here. LDX plus MDY plus NDZ is equal to 0. And L1dx plus M1dy plus N1dz is equal to 0. Now, the variables are separated. So integrating, we get first set of solution u of x, y, z is equal to C1. And for second set, means second equation L1 dx plus M1 dy plus N1 dz is equal to 0. This is again the one correction, that term is here. This term is here, x. Okay. In place of z, there is the term. It is not dx. It is L1, it is not z. L1 dx plus M1 dy plus N1 dz is equal to 0. And if we integrate it, we integrate this both the equations, so then we have the solution u of x, y, z is equal to C1 and u of x, y, z is equal to C2. So these are the two sets of solutions here. So equation 1 and 2 together constitute the solution of the system. Like the first method, grouping method, there also we have two sets of solutions. Like that, here also in the second method of multiplier, there are two sets of solutions here. Now see the example. The examples are: solve dx upon mz minus ny is equal to dy upon nx minus lz is equal to dz upon ly minus nx. This is the clear that it is symmetrical simultaneous differential equation. Now we want the solution for this differential equation, and you know that there are two methods, either grouping or method of multipliers. Now we cannot do the we cannot use here the grouping method, because in denominator the subtraction terms are there, so we cannot separate the variables easily. So we will try for the second method, means method of multipliers. Now you choose the multiplier, so that after multiplying by these multipliers, and if you add all the terms in denominator, the denominator term must be 0. Now here use multipliers L, M, N. Now if we use the multipliers L, M, N, then each ratio means C. In numerator also you multiply by L, M, N, because we are multiplying in denominator by L, M, N. So the term will be LDX plus MDY plus NDZ upon, you multiply first term by L, so that the terms are LMZ minus LNY. You multiply second term denominator by N, so that you will get MNX minus MLMZ. You multiply third term by N, so that the term will be LNY minus MNX. Okay. Now you do the addition of all the terms. If we do the addition, we are getting it 0 here. So denominator is 0, so that numerator term is also 0, and so LDX plus MDY plus NDZ is equal to 0. Now variables are separated because LMN are the constant terms. So here variables are separated. So integrating, we get that L is constant, integration of dx is x, plus M constant, integration of dy is y, plus N constant, integration of dz is z. So the solution is Lx plus My plus Nz is equal to C1, constant of integration. We are integrating, so the constant of integration is here C1, because we want two sets of solutions. So first, for first set, we were using here the constant of integration C1. Okay. Now again find the second set of solution. Suppose here Second set of solution is x, y, z. Means you multiply the numerator terms by x, y, z respectively, x dx plus y dy plus z dz. And in denominator also, first term you multiply by x, second term by y, and third term by z. So the terms will be here like this. Each ratio is equal to x dx plus y dy plus z dz upon mzx minus nxy plus nxy minus lyz plus lyz minus m minus here mxz. The terms are like this. So mzx and last term mxz get cancelled. Minus nxy plus nxy get cancelled. Minus lyz plus lyz get cancelled. So denominator, we after multiplying by multipliers, if we do the addition of denominator terms, we are getting it 0. So that numerator terms also 0. So we have the second equation x dx plus y dy plus z dz is equal to 0. So here variables are separated. So integrating we get now integration of x with respect to x is x square by 2. Middle term integration of y with respect to y is y square by 2. Integration of z with respect to z is z square by 2 is equal to c2. Second set of solutions. So constant of integration we take here c2. Okay. So this is the second set of solution. X square plus y square plus z square is equal to c2. So this is the example. In this example, we have two sets of solutions. First is Lx plus my plus nz is equal to c1, and second set of solution is here x square plus y square plus z square is equal to c2. Now second example, here solve dx upon 3z minus 4y is equal to dy upon 4x minus 2z is equal to dz upon 2y minus 3x. Now you choose the set of multipliers so that after multiplying by these multipliers and adding the denominator term where the value of denominator 0. Now using multipliers here x, y, z. So x, y, z are the multipliers. If we multiply the first term denominator by x, the term will be 3xz minus 4xy is equal to denominator term, middle term, denominator term, you multiply it by y, 4xy minus 2yz, and third term, you multiply it by z, 2yz minus 3xz. And if we do the addition of all the terms, then its value is 0 here. Now the denominator term is, the addition of denominator term is 0. So you multiply numerator term by also by the multipliers x, y, z respectively. So that we will get the term x dx plus y dy plus z dz. Now denominator is 0, so obviously numerator term is also 0. X dx plus y dy plus z dz is equal to 0. Now variables are separated, so integrating we get x square, integration of x is x square by 2. Middle term integration of y is y square by 2. Third term z dz, integration of z is z square by 2. Now you multiply that every term by 2 so that we can remove the denominator term 2, and so that we have the solution x square plus y square plus z square is equal to c1. So this is the first set of solution of the example. Now another set of to get the another set of solution, use here the multipliers 2, 3, 4. It is on trial and error basis. You have to find the set of multipliers in your logic. So 2, 3. If we multiply first term by 2, second term by 3, and third term by 4. And if we do the addition of all the denominator terms, then we have the value 0. So this is the second set of multipliers 2, 3, 4. Now denominator is 0. You multiply numerator also by these multipliers 2, 3, 4. So and you do addition of all the terms. So we have the addition 2dx plus 3dy plus 4dz upon 0. So that denominator is 0. So numerator term is also 0. So 2dx plus 3dy plus 4dz is equal to 0. Now variables are separated here. So integrating we get 2x plus 3y plus 4z is equal to C2. Okay, so this is the second set of solution. Second set of solution. So here also in this example, we have two set of multipliers, and so we have two set of solutions. The first set of solution is x square plus y square plus z square is equal to C1, and second set of solution is here 2x plus 3y plus 4z is equal to C2. Okay. Now these are the examples. We try to solve. We take it as a homework and try to solve. Dx upon y minus z is equal to dy upon z minus x is equal to dz upon x minus y. And the hint is given that multipliers are given 1, 1, 1 and x, y, z. Using these multipliers, we will get two sets of solutions. Second is here. Second example, dx upon x into bracket 2y raised to 4 minus z raised to 4 is equal to dy upon y in bracket z raised to 4 minus zx raised to 4 bracket complete is equal to dz upon z into bracket x raised to 4 minus y raised to 4. So to find the two sets of solution for the second example, the sets of multipliers are here given 1 upon x, 1 upon y, 2 upon z, second x cube y cube z. Try yourself and try to find the solutions for the example. And so here, the second method of multipliers is over here. So we have discussed two methods to find the solution of symmetrical simultaneous differential equations. First, grouping method, which was discussed in previous lecture. And in this lecture, we have discussed the second method of multipliers. So this topic, symmetrical simultaneous differential equation, is over here. And all the methods topics are covered of first unit. So thank you.